today, 1.3, this is called extrema and end behavior. So we're going to talk about maximums and minimums, and then the end behavior of functions. Okay, I'm going to write my name up here. Don't write my name. You can write your name. Sometimes people are just so used to writing down what I do, they write Miss Whipple on their paper. So we are going to identify extrema of functions today. Some of you might be thinking, what is an extrema? That is just a maximum or a minimum value. Okay, it comes from, these are extreme points, so extremely high or extremely low. You guys have looked at maximums before when you studied quadratics. Probably haven't done a lot with those, but you have found the highest point, or for the minimum, you would have found the lowest point. Okay, and then what's new today is what's called a relative maximum and a relative minimum. So when I say that you've done like the max and the mins before, what I mean is you've seen a graph where there's a maximum. It looks like this. Okay, so a parabola where this is, oh, that's not a maximum. What is that? It's a minimum. So good thing Miss Whipple bought some cool white out this year. Okay, so the maximum is going to be like this. Okay, and then what's different about the relative max?
Please put your brown recycling bin outside of your classroom if you have not already done so. Thank you.
Okay, a relative maximum, okay, means that it is the highest point in that area. Okay, so it's located at a point on the graph where no other nearby points have a greater y-coordinate. Sometimes it's called the local maximum because it's the highest point in that area. It's not the highest point on the graph because really, what is the highest point on that little graph that I drew there? Yep, infinity, okay? So the minimum works the same way. It's the lowest point on the graph or the lowest point in an area. Okay, so where no other nearby points have a lesser y-coordinate. And they both have a plural form. So minima, if there's more than one. Maxima, if there's more than one. And then I drew the minimum a second ago. Okay, it's a parabola opening up with the lowest point. And then I'm going to draw an example for you that has more than one. So the relative minima, when there's more than one, could look something like this. Okay, so in this area, this would be the lowest point. In this area, this is the lowest point. So there's two relative minima there. All right, and then for our first example, we are going to identify and estimate the x and y values of the extrema. This says round to the nearest tenth if necessary. So when you do this on your homework, if it's not exactly on a point, you can do your rounding to the nearest tenth and you just have to be around that point. The ones that we're looking at here, a lot of them are exact values. So we're going to find the relative max and we're going to do the relative min. Okay, and we are going to write each of these as a point. Okay, so this is going to be in point form, which means it'll be x, y. Okay, so want you to take a second, try 1 and 2. If you do those really quickly, you can go ahead and try the other ones. So you're listing those as a point. Yes. All right, so for our relative maximum, Heidi, can you tell me what you got for the relative max for number 1? Great. Okay, and then, Kanan, what'd you get for the relative min? Great. All right. This one looks like it is. Did you round to something that was close to that? I'd be okay with that. Well, you'd have to do negative 1.9. Okay. Yeah, be negative 1.9, because that would be the negative 2. Oh, for the height. Gotcha. Sorry, the max. All right, and then the relative max here, we should have got 1,4. And the relative min would be negative 1, negative 4. Okay, remember if there isn't a scale, the scale is what? 1. All right, for this one, your relative max, there's only 1. And if you look at this scale, we're going by what? 4s. Okay, this one is kind of tricky. Like, this is the line here, and it looks like it's a little bit above that line. If you just put like your point on there, you might run into it. So the answer for this was 0, negative 3. Okay, but I know that one's a little bit tougher to see. And then there are 2 relative minima. What's that? Not the negative 2, because that would be more halfway. And like I said, this one is kind of hard to see, but if I do my line, I can see it's there. I'd rather have you rounding to like negative 3.5. Like if you did something like that, I would count that. And then your minima here, same thing. So this one we can definitely see it's not all the way to the bottom, so it's not at negative 20. Okay, so I estimated negative 19. And then 2, negative 19. Okay, and again, if you're close to that, that's fine. And just remember here, the Y scale is by 4s. So that's why we want to pay attention to that part. Okay, and then here we have relative maxima. So we should have got negative 1,6 and 1,6. And then the relative min is right here at 0.5. Okay, how did those go? Okay, and so for some of the ones when you're estimating, you might not have the same answer as somebody next to you, and that's okay. All right, now we're gonna deal with a real world application. So there is a video game. Carlos's score on the video game after X minutes is modeled by the graph. Okay, so there's two things that this is going to represent. So it says X minutes. Do you guys know what the Y is? Not minutes. It's the score. Yeah. Okay, so the score is going to be the Y value. Okay, so we're just going to write that on here. So this is the score after X minutes. And then we're going to estimate. It says estimate the X coordinates. So you only have to say the X coordinates and not the Y. Okay, for the relative min and maxes. And then we are going to describe the meaning of the extrema in context of the situation. Okay, which we practiced some of that yesterday, so we're going to do more of that today. All right, so we don't have anything labeled here, so we know it's going by 1. So 1, 2, 3, 4, 5, 6. This is just really to help us understand what's happening here. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's a few places where we have a max. Again, you're looking for max values in an area. So this would be a max. This would be a relative max. Okay, so the relative maxima occur at, and then we're going to use the x equals. Okay, so they occur at, so let's find the x values. So we just go straight down. The x values are 2 and 5. So they occur at x equals 2 and x equals 5. Okay, the relative minimum occurs at, and here's our minimum, so we just have to find where that is on the x, and again it's because of this direction, estimate the x coordinates, so the relative min occurs that x equals what? 3. Okay, and then we're going to describe the meaning of that situation in the context. So we're going to make sure we mention the score and the minute. Okay, so one way you could word this is you can say Carlos's scores peak at the 2-minute and 5-minute marks. Okay, you could also say Carlos's scores are the highest at 2 minutes and 5 minutes. That would be fine. Okay, that's a different way to say it. And it dips at 3 minutes. Okay, again, you can also say Carlos reaches his highest scores at 2 and 5 minutes and his lowest score at 3 minutes, and that would be great. Okay? Yeah, when there's a S at the end of the name, do you guys know you can either do it like this or this? You can either use an apostrophe at the S just like that, or you can do that. It's easier. Okay, so the end behavior of a graph describes what happens at each end. Okay, so it's describing what happens as x approaches positive infinity or negative infinity. So that means we want to know what's happening as the values of x get very, very large or very, very small. we know that in every single graph, there are always how many ends to a graph? Each one of these graphs has how many ends in it? 2. Okay, so there are 2 ends to each graph. The left side and the right side. Left side, strong side. For all my Remember the Titans fans out there. Okay, so we're always going to describe what happens on the left side and what happens on the right side. Okay, we're going to use the symbols negative infinity and positive infinity, which is just infinity. Okay, and we're going to use that to tell if the graph is rising or falling. So what we do is we use the symbols infinity for x and for y, and we use the symbol negative infinity for x and for y. So they mean 2 different things depending on what part of the statement you are writing, okay? So you are always going to use this format. So we're going to put this in a happy cloud here. As x goes to negative infinity, y goes to blank. And as x goes to positive infinity, y goes to blank. So you can use this for every single problem that's asking you to do the end behavior, okay? Now, you can see the x's are already filled in. That's because of what I told you here. Every single x is going to have 2 ends. So if it is on the left side, you are going to negative infinity. Okay, so this is as x goes to negative infinity, that means what's happening on the left. And as x goes to positive infinity, that means the right side. Okay, bless you. So this has to deal with the x-axis. Okay, anytime you're talking about x, infinity means right, negative means left. For the y, it's a little bit different. For y, you are going to fill in the blank spaces with the positive infinity if the end is going up. Okay, and you're going to use a negative infinity if the end is going down. Okay, so if it is going up, you're going to use positive infinity. Okay, so for the y, it's up or down. For the x, it's left or right. Okay, so when it says describe the end behavior, what we're going to do is we're going to write a mathematical sentence. So I gave you that sentence stem, and we're going to be filling it in together, okay? So our sentence is always going to start as x goes to negative infinity, y goes to, and then I'm just going to leave that blank. We'll fill it in together. Sorry, I'm going to connect this so that looks better. As x goes to negative infinity, where does y go? And you don't have to write the and part. We're just going to write as x goes to positive infinity, y goes somewhere. Okay, so when we're describing the end behavior, all we have to do is look on each side of the graph. Okay, so for the left side, we just have to look and see where it goes. On the left, is it going up or down? It's going up. Okay, so on the left side of x, if it's going up, we're going to put positive infinity. Okay, and then for the next one, we're just going to look at the right side. On the right side, it's going down, which means on the right, y is going to negative infinity. Okay, so this is your statement. Again, this is saying what happens on the left. This is saying what happens on the right. You guys think you feel good enough to try the next couple? Again, we can start them the same as we did before. It's always as x goes to negative, where does the y go? As x goes to the positive side, where does the y go? And then you have to figure where the y is going. Okay, so we're going to take a couple minutes to try to fill those in. All right, it looks like some of us are doing pretty good. All right, so on the left side, we're going up or down? Up or down? Yeah, we're going up. So this is going to be positive infinity. On the right side, we're going up. So they're both going to be positive infinity. All right, and then both of these are going down. Okay, which means this is negative infinity and this is negative infinity. Okay, so when you're doing problems like this, you do not have to show your work here. Okay, this is to help you understand why we're doing these things. So when you're doing it by yourself, you know how to. Okay, and then is this the left side or the right side? Left. So on the left, we're going down. On the right, we're going up. So I have negative and then positive. Okay, how are we feeling about those? Pretty good? All right, now with M behavior,
The whole thing on one side of the graph.
so even if it is all negative values, you're always going to have a left or a right side. That's yeah, that's a good question. Like if this was all over here, you still just look at the left side, the right side, even if it's placed in a different quadrant. Okay, and then what we're going to do now is apply N behavior to a real world situation. So this graph is going to show the height, y, of a ball that is thrown from a balcony after X amount of seconds. So we're going to have to describe and interpret the N behavior in the context of the situation. Okay, so the first thing we're going to write down are just some notes on what's happening in the situation, and then we'll come up with a statement together, okay? So when you're looking at this, your height, what's the lowest height it can have? 0. Okay, so this is your lowest y value. Okay, and then what about time? The time can't be what? Negative. Okay, so this is also your lowest x value, and that can't be a negative value. So time can't be negative for this function because this is going to affect the way that we're going to write the end behavior. So this is a little bit different than what we were doing above. So time can't be negative. So the function is not defined when x is less than 0. Okay, the function is not defined when x is less than 0. So let's think about how that affects the end behavior, because anytime we did end behavior, the first thing we wrote down was as x goes to negative infinity. Is x going to be going to negative infinity here? No, so you are not going to write that. So there's no end behavior as x approaches negative infinity. So you are not even going to write that in your statement. Okay, and this is the reason why. You don't have a negative time value. So the only thing we have to write for our statement is what happens as x goes to positive infinity, which we've already talked about that a little bit. So as the values of x, which is the time, increase, what is happening to this? Where's it going? Okay, it's going down, and what's the lowest value? Yep, so down approaches 0. Okay, so this is not going to negative infinity like we were doing before. Okay, the lowest value it's going to hit is the ground, because you're throwing a ball, right, from a balcony. Okay, none of us are strong enough that we're going to throw something and it's going to tumble through the ground to the earth's core. So 0 is realistically where we are. So we're going to write y approaches 0. Okay, so this is going to be our end behavior, and now we are going to describe, now we're going to interpret that. Okay, so this was our end behavior that we described. Now we're going to interpret that in context. Okay, so all this is saying is that as the time passes, the height of the ball is approaching 0 feet. Okay, as time passes, the height of the ball approaches 0 feet, because what's happening? What is the ball doing? It's falling to the ground. Just like the leaves on the trees very soon. Okay, so everything I'm putting in this cloud, that is part of your answer. Okay, everything else we wrote down is getting you to this answer. Okay, so we don't have end behavior here. And what we do have happening is that as the time passes, the height of the ball approaches 0 feet because it is falling to the ground.